Hello everyone. Today I am going to present you my digital design project. My name is Berkay Yazıcıoğlu and this is my project LED Cube. In this project I constructed a LED cube like that, and the constructing design is that in the layers, the horizontal layers, on the cathode legs are connected, and the vertical layers only the anode legs are connected. Therefore, if I wanted to light this LED, I will ground this layer and put this layer into VCC. Therefore, lighting this LED. In order to control all of the LEDs, I use 20 inputs, and then if I wanted to light this LED, I shouldn't be able to light this one and this one, because in that case both ones will be lighted, and that wouldn't be desirable. Therefore, I create patterns like that, so it changes its state. And if I wanted to look like these two ones are lighting together, I will just increase the clock. This clock is 1 Hz, and this is a testing pattern, and this is 200 Hz, and they all look like they are lighting at the same time, but actually they're not. So this is my main logic behind my project. So I will just show you the patterns and modules. These two were the test modules, and another test module is that the frequency increases automatically, as you can see. So I can hold a value, and that value gets set statically. So this clock, this pattern is 16 Hz now. If I wanted to it increases at speed of half a second, but after it reaches 50 Hz, it will increase more rapidly. As you can see, the change isn't even noticeable right now. Okay, these were the demonstrations of my testing modules. Therefore, that the finished state machines changed between these layers, and these layers are changing into 200 Hz. Therefore, they look like they are lighting at the same time. So I use that 200 Hz finished state machine in all of my patterns, and just change the raw inputs, and even though the layers change in 200 Hz, the output of the LEDs, the lighting LEDs, look like they change at the different speeds, because I changed the raw things in the wanted clock divider's frequency. So just another demonstration would be that this rain pattern. I call it rain pattern because it looks like raining. So in this one too, I changed the pattern inputs at 5.5 Hz, but still they run at 200 Hz as well too. And the randomness is done by linear feedback shift register. Yeah, this is like that. Another pattern is that I implemented this using different methods than the rain pattern. I use read-only memory here. It's just a demonstration of how to use a read-only memory. Okay, I actually have a cursor here. So in this mode, in the previous modes, that the patterns were preset, and you just see the pattern when you press the switch. But in this set, you can make a pattern as varied as you want. I use a 10 nibble RAM here, and when this cursor is located by the push buttons. So if I wanted to set a pattern, I will just click on the center button like that. So it puts into the memory that the setting pattern and the setting order is important. Program does it for me. Oops. Okay, it will not be much longer, just for the demonstration. Alright, I think this is enough to demonstrate. So, and after setting the pattern order, so I can set and unset, and in this mode I will select the frequency of this pattern that I created right now. So the left up and down buttons increase the frequency, as you can see. It is 7 Hz right now, and the left button just changes the index of the change of the frequency, like it's 17. I'm sorry, it's 17 Hz right now, and it increases 10 by 10 because I pushed the left button. Now it increases 100 to 100, and to undo that, only pushing the right push button is enough. Sorry again. So if I wanted to reverse the just begin the pattern at the time I want, I just push the center button in this mode. It just begins again, but it doesn't change anything. But if I want to reset that, there's a reset button here. So reset button resets the pattern you have set. So the final thing I have done with my project is a little game. So it says play here. So there are enemies coming up to you, and you just rotate the player here and you shoot them. You should not let the enemies come close to the layer that you are in. So if it happens, there is a lose message, and to play again you have to open again. So this was my digital project, everyone. I hope you liked it. The thing is, it looks easy, but the fact that you have to use finished state machines and many shift registers and many clock dividers to make it happen and work synchronously was a real thing to deal with. So thank you all for watching.